Going. Scale factors. They indicate whether an object has been enlarged or reduced. Okay. So enlargements, those images have scale factors that are larger than 1. Okay. Larger than 1. The shape hasn't changed, but the size has. But sorry, the image has increased in size. Seriously, dude, leave it. Okay. Now to find your scale factor, you take a dimension of your new image and you divide it by a dimension from your original image. Okay. So measure these two lines in inches, and what do you notice? This is 1 inch. This is 2 inches. Is that correct? Measure it. You need to know how to measure in grade 10, so this is your practice. Go ahead and do it. Okay. So, what do you notice? State the obvious, please. What do you notice? B is twice A. Okay. Now, some people said, well, A is half of B. You're right. But that means that's going in the other direction. We're going to talk about that in a second. So when I ask for the scale factor, I'm going to start right here from line A. I have to tell you what the original measurement is. And this to line B means that line B is the new image. If I had set it reversed, the scale factor would be reversed. So for our scale factor, for us, the original is line A, 1. Okay. Sorry, the new image is line B, which is 2, over the original, which is 1. Okay, so this equals 2. Always try and simplify. Okay, so our scale factor is 2, going from A to B. Now reductions, they have a scale factor, it's less than 1. So for example, 0.5, 2 over 3. Those are all numbers that are less than 1. Okay? All proper fractions, those are less than 1. The shape hasn't changed, but the size has been reduced. So for the next example, we have rectangles. We have rectangle A and B. They're both rectangles, different sizes. Please measure the length and the width of A, the length and the width of B. Go. So what's the length on the top? How many inches? 2 inches? What's that? Yeah. Can you go turn it off, please? What's the top length? Is it 2 or 3? 2? Okay, sorry, it looks a little longer. And this would be 1 inch. So then what about the bottom one? This is 1 inch. And this would be half an inch. Is someone in there? Okay, thanks. Okay, so well, what do you notice from A to B? Like, what do you notice about B? B is half of A. Okay. So now we're going in that opposite direction. So now we're saying that image A is your original and image B is the new image. So your scale factor equals new over original. The new image, just choose a measurement. Which one do you want to use? 2? Okay, so that's the length. Then we should use the length on the bottom one. Sorry, the new image is B. So it'll be 1. Okay. Then the original is 2. So it's 0.5. Or half. Either or would be fine. Okay. And if you reversed it, then the scale factor is still new over original, but your new image length is 2 and the original is 1 because A and B have switched from being new to original. Okay? And so this has a scale factor of 2. The fractions are reciprocals. You guys know what reciprocal means in math? Right? The fractions flip. So 1 over 2, and the reciprocal is 2 over 1. Okay? So notice that's happened. We have reciprocal fractions. What are some image devices that are great at enlarging images? Taking something that's really small, making it larger. Pardon?
Magnifying glass.
Magnifying glass.
Telescope.
Telescope. Slow down a bit. What else?
I think the sailors look through.
Telescope. It's same type of thing, I think. It says telescope.
Binoculars.
Yeah, binoculars. What else?
Camera.
Camera. That's a good one. Well, it doesn't even have to be a zoom, but think about a camera. I can take a picture of this whole room, and it fits on a little screen, or on a picture, right? Anything else? Yep.
Most electronic devices.
Yeah, a lot of electronics, right? Computers.
That's what I saw. Yes.
Glasses. Yep. Depends what kind of glasses you have. Glasses and computers, they can go in the middle because they can do both. Right? What about? Sorry, I said enlarging. I shouldn't have camera there. Camera doesn't enlarge an image. Well, I guess it can if you zoom.
Just cross it out.
Yeah, cross it out. It's better at reducing. Okay. And computers. These ones are both. I know. We'll just draw an arrow. There we go. Okay. What else are good at reducing images? Microscope. Microscope would be good at enlarging.
Oh, the side mirrors you have on a car.
Yeah, that's right. That would be.
Mirror make appear closer, farther than they are.
So that would be reducing.
Yep.
Car. Okay. Good. So, just to review, scale factors. If you have a reduction, the scale factor is less than 1. Right? So you're looking at 1/2, 2/3, 0.95. Anything that's less than the number 1. Neither, that would have a scale factor that's equal to 1. So the dimensions are exactly the same. An enlargement would have a scale factor that's greater than 1. So for example, 4 over 3, 1.2, 6. Those all are enlargements. Okay. Question, Alouette? Okay. Drawing enlargements and reductions. So, method 1, you measure, use the scale factors. So draw a rectangle that has a scale factor of 1.5. Multiply this by 1.5, what do you get? Multiply that by 1.5, what do you get? So this will equal 3. This would equal 4.5. So when you draw your new rectangle, you're going to draw it 3 centimeters by 4.5 centimeters. Go ahead, draw it. Okay. Practice measuring. You should know how to use a ruler. If you need help, I'll help you later. Maybe get Dad to help you, or Mom. Next, draw a rectangle with a scale factor of 0.5. So you take your 2 centimeters and multiply it by your scale factor. And you take your 3 centimeters and do the same thing. So you need to get the new dimensions. Okay. So now you can draw your rectangle again. This time, of course, draw it with the new dimensions. Okay. And measure it just like I did. So, method number 2 is using different size grid. We have 0.5 centimeter. That's the small, medium grid, sorry. Check that. I'm screwing up here. We have 1 centimeter, which is in the middle, 0.5 centimeter, which is the smallest, and 2 centimeter, which is the largest. Okay. So in the bottom, you can see that the size talks about the dimensions of the square. So what we have here is we have a cross, or X, wherever you want to look at it, and it's 1 square, 2, 3, 4, 5. So when we draw it, okay, we would draw it using same number of squares, but is it the same size? No, it's increased. What was the scale factor going from 1 centimeter to 2 centimeter grid paper? Yeah, it's a scale factor of 2. Okay. So from 1 to 2, the scale factor would be new over original. So it would be 2 over 1, which would be 2. Okay. What about the scale factor going from 0.5 to 2? So scale factor would equal the new over original. The new would be 2, the original would be 0.5. What would be your scale factor? 4. So if you went from here all the way to here, your scale factor would be 4. Okay. And so we can draw on here 1, 2, 3, 4, 5. Same number of squares. So if I said increase it by a scale factor of 4, if you start here, just go up to 2 centimeter grid lines. Okay. What about going from 1 centimeter to 0.5? Your scale factor would equal 0.5, or 1/2. Okay. So doing the math the long way, new over original, the new would be 0.5, dividing it by 1, 0.5. And the last combination would be going from the large one to the very small one. So we would flip our fraction. Okay. New over original stays, but now the new becomes 0.5 and the original is 2, so that equals 1 over 4, or 0.25, a quarter. So that's if you go in the other direction, from the large squares to the very small squares, your scale factor would equal 0.25. Okay. Now going from here, your scale factor would equal 2. And going this other direction, your scale factor would equal 0.5, 1/2. So you can have 1, 2, 3, 4, 5, 6 different ways of drawing it. Okay. The last method is using the same grid paper. Okay. So what we want to do is draw a 3 by 4 rectangle. So 3 by 4 squares. There's your original. Okay. Now you want to draw another one, which I'll use red, using scale factor of 0.5. So you would do what we did at the beginning. Take your dimensions, multiply it by the scale factor, and so now you have the dimensions of your new rectangle. 1.5 squares along the top, 2 squares down. Oops, I did that backwards, sorry. 2 squares across the top, 1.5 down. Okay. There you go. So this is A. Try B now by yourself. Go. Get your dimensions first, then draw it. So I had to redraw mine 3 times just to make sure I had the right dimensions. Okay. So I got 8 squares across. Right. 1, 2, 3, 4, 5, 6, 7, 8. And then 6 going down. 1, 2, 3, 4, 5, 6. That's why you want to use pencil. And so this would be the answer for B. Notice how I maximized my space. I used it wisely. I didn't start drawing in the middle of the grid. Quit playing footsies. Okay?
It's accident.
Sure it is. Yep.
We all know that one.
Yeah, we know. Okay,
Look who's talking.
Sean's just jealous.
Yeah.
He or she is.